Welcome again to CH5010. So today we are going to do a couple of problems of tutorial. Before that, we'll just go over a couple of things, right? So these are the problems for today's tutorial okay, and the problems that we are talking about are things that we have discussed in the previous lecture, okay? So what we are talking about is basically you will have species balance and you have energy balance. Okay, so for a CSTR, when you have an energy balance, that will express temperature in terms of temperature in your parameters and your concentration. Okay, your CA is expressed in terms of CA in parameters, and then you have a temperature dependence because of K naught e to the power minus E by RT. Okay, so essentially you will have to solve these two equations together. Okay, in design problem, your X A or CA out is given. Okay, so from the first equation, from equation 1, you will calculate temperature. From equation 2, because you know CA out, you will calculate Q or V, or more broadly you can say tau, the residence time. Okay, so that is the design problem. Okay, so CSTR simulation problem, tau is given, and then you have to calculate basically CA and temperature. Okay, so in that case you will have to solve basically two non-linear equations, you will have to solve together. Okay, the other problem that you are given is let the desired temperature be 350 Kelvin. Okay, so in the first expression, what you are given, today's problem 2, given T out from CSTR. Okay, if T out is given from CSTR, you will calculate CA out or XA from equation 2. Okay, and then use T out, CA out to calculate the heat that needs to be removed. Okay, so that is the process that you need to follow. In both cases, because you have, why you can do this so easily, you can do this so easily because you have single reaction. If you have multiple reactions and multiple species, you will have to use numerical approaches. What we are going to do in the next class tomorrow's class, same example in PFR. Okay, same example in PFR, your mass balance or species balance. Okay, and because of this you can write it as Q rho Cp hat and you will get the same type of equation, same type of okay, and this is what we are going to do in the next class. Okay, and you can read ahead with respect to the design. Okay, the design equation part I'm not going to cover. This is something that we've done in undergraduate, so this is self reading. Okay, but the idea is that you can write your CSTR, desired volume, in terms of conversion, and in batch reactor you can write your desired time in terms of conversion. If conversion is given, then what is okay, and in PFR you can write the desired volume in terms of conversion as well. Okay, and this equation directly comes from a couple of the only assumption is that there is a single reaction, so RA can really be temperature dependent as well. Okay, and that leads us to volume of CSTR, PFR, and so on of this nature. Okay, so this is what we are going to do in the next. So this is self reading. What we are going to do in the next class is basically solve an example of PFR in two different ways. One is hand calculation, and other we are going to solve it using Excel. Okay, and the reason for using Excel is then we will go on and demonstrate a more complex problem using Excel as well. Okay, so that's the aim behind this. Okay, I'll talk about what's the aim of tomorrow's class and tomorrow itself. Okay, but that's the game plan. So today, please complete the tutorial.